All right, college algebra final review. All right. Starting off, we have solved this inequality. Okay. Now, first of all, see it's a greater than. When you have a greater than, when you graph this, you're going to have two values, and they'll go opposite directions, so it look like this. Okay, so it'll be greater than that value, less than this value. I colored these in just because I had to, it was kind of hard to see, but these won't be colored in because it does not have an equal to line. If it's a less than, your two values will connect. Okay. Now, all I do here on this, I do the square root property. Square root both sides. The square root cancel the square, so we have x, and then the square root of 144 is going to be plus or minus 12. All right, which means x is going to be greater than 12, and x will be less than negative 12. So it'll go opposite directions like this. So it looks like it's going to be this right here. It'll go from negative infinity all the way up to negative 12, and then it'll go from 12 to positive infinity, right there. Okay. Number 2. Solve this equation using a quadratic formula, right here. Now this is breaking down in steps. It says find A, B, and C. So right there, my A is 1, my B is positive 3, my C is a negative 2. All right, now let's break it down to the discriminant here. Find the discriminant, which is b squared minus 4ac. All right, so b squared minus 4ac, so that's going to be 3 squared minus 4 times a, which is 1, times c, which is negative 2. Okay, so it's going to be 17. Okay, and then solve the equation. Use the quadratic formula. So this is the discriminant we just did there. So this is going to be x equals negative b, which is a 3, plus or minus the square root, which we got this discriminant, all over 2a, and my a was a 1. Okay, so it's going to be negative 3 plus or minus the square root of 17, all divided by 2, and there's no simplifying you can do there. So I think it's it. And yeah, there it is, in there. So we're in good shape. You can type it like this, or you can separate them and type it that way, either way. Number 3, find the length of a rectangular lot with a perimeter of 134 if the length is 5 more than the width. All right, so let's draw this out here. And the key is right here. The length is 5 more than the width. The width is smaller, so I'll let the width be x. This is x and this is x. So that means the length is 5 meters more, so it's going to be x plus 5. And that'll be x plus 5. And so there's all my sides in terms of x. Well, if I add these expressions together, that'll be my perimeter, which is 134. So I'm going to add these 4 expressions. So it's going to be 1, 2, 3. It's going to be 4x, and then plus 10 equals 134. And then I just solve this. So minus 10. This will go away. So 4x equals 124. And then divide by 4. It's going to be 31. Okay, so x is 31. So that's my width, which 31 plus 5 is 36. And that's what it asks for. Now, you be careful now. Don't snap and get 31 there, because that's not your answer. It's asking for the length. See, the 31 is the width. So the answer is D here. So be careful on that. Make sure you're answering the right thing. All right, number 4. solve this equation. All right, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, now my a is 1. That goes here and here. B is 9, here and here. And then C is negative 22 all the way over there. Okay? And then after you put these numbers in, there's 1, 2, 3 different things to do at one time. All right, so it means x equals negative 9. Down here, 2 times 1 is 2. And then my, let's see here, plus 88, 81, 169. Okay, so inside the radical is 169, and the square root of 169 is 13. So that means I've got x equals negative 9 plus or minus 13 divided by 2. All right, negative 9 plus 13 is 4. 4 divided by 2 would be 2. There's one answer. Negative 9 minus 13 is negative 22. Negative 22 divided by 2 is negative 11. There's my two answers, negative 11 and 2. That's the first one. A. Okay. Now, look at this one. Find two consecutive integers whose product is 420. Two consecutive integers whose product is 420. Now, two consecutive integers, I have to write them out in terms of x because we don't know either one. But if the first one is x, the next one's going to be x plus 1. So like if this is 30, then 30 plus 1 would be 31. There's two consecutive integers. If this is 26, 26 plus 1 would be 27. Okay. Well, it says the product is 420 of these. So if I multiply these together, I should get 420. All right, so if I distribute here, I'm going to have x squared plus x equals 420, and it's quadratic, so I'm going to have to minus 420 and do the quadratic formula. Okay, so I'm going to do the quadratic formula here. All right, so let me move it up a bit. All right, x equals negative b plus or minus the square root b squared minus 4ac all over 2a. All right, my a is 1. B is 1. C is negative 420. Okay, and then there's 1, 2, 3 different things to do here. All right, so x equals, all right, right there it's a negative 1. Down here, 2 times 1 is 2. And then in my discriminant, that's going to be 1 plus 1680, 1681, I think. You do it on the calculator, make sure. I think it was 1681, but 1 squared minus 4 times 1 times negative 420. All right, 1681. Now do the square root of that answer. 41. I went ahead and did it. So negative 1 plus 41 would be 40. 40 divided by 2 is 20. There's one answer. Negative 1 minus 41 is negative 42. Divided by 2 would be negative 21. All right, so there's my two values for x, which means this one right here is either 20, which means that would be 20 plus 1 would be 21. And then this value right here would be negative 21, which means negative 21 plus 1 would be negative 20. So there's my two answers, which is C. Okay. All right. Now, number 6. Decide what values of the variable cannot possibly be solutions for this equation. Okay. Now, what this is talking about here, where I'm dividing, I cannot divide by 0. So I have to figure out what values of x is going to make me divide by 0 because I have to exclude those. So right here, 5x, well, 5 times 0 would be 0, so x cannot be 0 here. If I look at this one, same thing, x cannot be 0. So 0 is the only value that cannot be included. So that's pretty simple. 0. Okay. All right, going to number 7. Solve this equation. Now on this one, all right, now we see 0 is excluded. We can't have 0 as a solution, so we got to keep that in mind. If we get 0 as an answer, now after I solve this, that's going to be D, is going to be the empty set. All right, so let me write it out here. 2 over 7x plus 7 equals 3 over 8x. Now spread this out so I can multiply and get common denominators and stuff. So looks like I got x here, and I got a 7 and an 8. The common multiple for 7 and 8 would be 56. So I'm just going to multiply 56x on both sides. Okay. Now, I think what I'm going to do is I'm going to distribute this. So I'm just going to write this over here, 56x over 56x right here. So I'm going to distribute it there, and I'm going to distribute it there. And there's a plus in front of this. All right, so when I distribute here, the x's will cancel, and then I just multiply 56 times 2 divided by 7, which is going to be 16. And the x's cancel, so there's no x's. Plus, now I do 56x times 7. All right, so it's 6 times 7 is 42, 4, 30, 392x. Okay. Equals, now over here, my x's will cancel. See, I'm multiplying this, but I'm dividing that one. So this is going to be 21. Okay. So you can just use your calculator. 3 times 56 divided by 8. Now I'm going to minus the 16 on both sides. So I've got 392x equals, and that's going to be a 5. And now I'm going to divide by 392. There's my answer, and it looks like right there, C. Okay. Okay. Number 8, give the domain and range of the relation, and does relation represent a function? Okay, let's see here. I've got 1, -3, -6, and 4. That would be my domain. Okay. So in order, be -6, -3, 1, and 4. -6, -3, 1, 4 could be this one or this one. I know these two are out because they don't have the right domain. Now what about the range? My range would be 9, -8, -4, -8 again. So if I put those in order, -8, -4, and 9. -8, -4, 9. All right, both of these have the right domain and range. Now, is this a function? Okay, I got 1 paired up with 9. Do you see 1 paired up with anything else besides 9? No. -3 is paired up with -8. Do you see -3 paired up to anything else besides -8? No. -6 is paired up with only -4, and then 4 is paired up only with -8. So this is a function. So this would be down here, yes. So it's D. That's right. Okay. Number 9, does this one show a function? Does this relation show a function? Yes, no matter where I draw a vertical line, I will only hit it one time. So the answer is yes. Okay. What about this one? Does this one show a function? Well, look here. If I draw a vertical line right there, I'm going to hit it 3 times, man. You can't hit it but once. So this is no. Okay. 11. graph this equation. All right, we got to pick which one's the right one. Well, there's my slope, and there's my y-intercept. So that means if I go up 4, it should cross at 4. So if you look here, 2, 4, see right here, this one don't cross. That ain't right. See here, 1, 2, 4, right there. That one crosses. All right, now my slope is 1/2, which means it goes up 1, and it goes to the right 2. Or if I go up 1 and over 2, it's going to put me like right there, and that's not right. All right, this doesn't go up 4, so this one's out. It's got to be this one. Let's see here. It goes up 4, yes. It goes up 1 over 2, yes. D. Okay. Graph this one, same thing. All right, there's my slope. There's my y-intercept. This is my slope. That's my y-intercept. All right, so this one should go down 4. So here you go, down 4 right there. And then it should go down 1 and over 2, 4, 5. I think this one's it. I think it's A. It sure is A. Okay, now if you look at this one, going down 4, this one don't even go down 4. This one don't go down 4. Now this one does. It goes down 4, but if you notice, it goes up 1 over 5. It does not go down 1 over 5. See, it's negative. So it should go down 1 and over 5. That's my slope. The answer was A. All right, what about 13 here? Write an equation for the line that passes through these points. Give your answer slope-intercept form. All right, so the slope formula, remember, the y from point 2 minus the y from point 1 over the x from point 2 minus the x in point 1. All right, so that's how I find the slope. So here's my points. This is point 1, that's point 2. The y in point 2 is negative 3. Minus the y in point 1 is 1. The x in point 2, that's 0. Minus the x over here in point 1, well, that's 2. Okay. So negative 3 minus 1 would be negative 4. 0 minus 2 is negative 2. Simplify that, that's 2. So my slope is 2. So if I look at these, all right, it could be A, could be D, because both of these have the slope of 2. It's not this one, because that says negative 2. That one says negative 2. It can't be those two, because those have the wrong slope. It's got to be A or D. Now what I'm going to have to do is find my y-intercept. So what I'm going to do is I'm going to take my 2. I know it's y equals 2x plus b, because I don't know the y-intercept value. I got to figure out what that is. Well, look here. There it is right there. Because see, there's x is 0. That's my y-intercept. So it's negative 3 right here. It's got to be D. Because see, I got a negative 3. This is a positive 3. Can't be that one. So the answer is D. Now, if you didn't have that, you just take your point and plug it in. So I would put 2 in for x. Now this is if you didn't have, like suppose this was 5, 7 or something, you know, instead of 0, negative 3, you didn't have the y-intercept. So I'd take 2, put it in for x. I would take 1 and put it for y. So I'd have this. Then 2 times 2 would be 4. And then I'd have to minus 4. And look, I get negative 3. So that's how I'd find it if I didn't have it given to me. Okay. All right. Graph this function here. All right. This is a piecewise function. All right. So what we're going to focus on is the transition value right here, where it transitions from that piece to this piece, which is 1. So I'm going to put 1 in this top piece. Well, if I put 1 in there, I'm going to get 4. So if I put 1 in for x, I'm going to get 4 for y. So I should have that point, and see it's equal to, it should be colored in. All right. So if I look at 1, 4 right here should be colored in. It's not even there. That's not it. 1, 4, there it is, but it's not colored in. 1, 4, well, look here. That's going to be plain and simple right there. This has got to be D here. Okay. Now, if you did have a couple possibilities still, all right. Now look, this is 4, which means it's going to be a horizontal line. So it's a constant. So it's going to be straight across because it's greater than 1. So it's going that way. Now this one's less than 1. So if I put my 1 in on it, -2 minus 1 would be -3. And it's not colored in because it does not have the equal to line. So you can see here 1, -3 is right there. All right. Then I would pick a value that was less than 1 and plug it in to get another value. So -1 would work, I guess. So if I put -1 there, -2 minus -1 would be -1, wouldn't it? So -1 is right there. You see it? So that confirms that's the line. Okay. All right, let's go to 15 here. When find fg of x when f of x is this and g of x is that. So we're going to multiply these together. So we'll multiply these two. All right, I'm just going to build a box and do my multiplication with this box. On the top, I got 9x minus 3. On the side, I got 8x minus 5. So we'll multiply these up. So right here, 9x times 8x is 72x squared. Right here, -3 times 8x is -24x. Down here, 9x times -5, that's going to be -45x. And then right here, -3 times -5 is a +15. Okay, so I've got 72x squared. When I add these like terms together, I'm going to get -69x, and then I got a +15. So that should be my answer right there, which looks like D. Okay. 16, find the domain of this when f of x is this and g of x is this. All right, so I got to do f minus g. So I got to do f of x minus g of x. Uh-oh, Gusty. Oh my goodness. Sorry about that. I'm so sorry. So f of x is 5x minus 8 minus g of x, that's 5x minus 5. Okay, now I need to distribute this minus into that expression here. So I'm going to distribute that, which makes this a -5x, makes this a +5x, and now I can just add them. So 5x plus -5x is just 0x, so that goes away. And then -8 plus 5 would be -3. All right, so this is the only value I get. I don't have any x's in it, so there's no issue with x at all. So x could be any value. I'm just going to get -3 every time. So there's no constraints or no omissions. So all right, 17. We're sketching this graph. Okay, now look here. We've got horizontal shift right there. And then right here we got vertical shift. This horizontal shift, remember now, it goes the opposite direction. So that means it's going to go to the left 4. This is vertical, which means it's going to go down 3. So my vertex should be at -4, -3. This is my vertex. Okay. So I just go to -4, -3, should be right here somewhere. That's not right. This is not right. Here it is, right there, D. Okay, I'm going back 4 and I'm going down 3. All right, graph this one. All right, this is a polynomial. All right, so if you look right here, this is all factored. Right here, x equals 0. -2 times 0 would be 0. So there's 0, 0. It's to the 1 power, which means it has a multiplicity of 1, which means it's just going to pass through at that value. So if you notice here at 0, see here at 0, it passes through. Right here, 0 passes through. Here's 0, passes through. Here's 0, it passes. So they all pass through at 0, like it should. So now I go to the next one. All right, my 0 here is 1. So x equals 1 is my 0 there. Now look at squared, which means it's multiplicity of 2, which means it's going to touch and turn. So at the value of 1, it should touch and turn. So here's 1 right here. Well, they don't even go through that one, so that one's out. All right, here's 1, and see how it touches and turns? See there, it's going up, touches and turns back down. So it could be this one maybe. Or this one, see here, at 1, it touches and turns, so it could be that one maybe. And at 1 here, they don't even go through that, so that's out. So it's B or C. Okay, now let's go to my last 0, which is -2. -2 plus 2 would be 0. So x equals -2. It's squared, which means it's multiplicity of 2, which means it's going to touch and turn also. All right, so at -2, well, look here, -2, see it touches and turns. So it could be that one still. And this one, see here, -2, it's going to touch and turn. So it's B or C. It's got to be B or C. We did all our multiplicities and our zeros. Now what we're going to have to do is the end behavior. The end behavior is from my lead term, which is going to be a product of the lead terms of each factor. So in this one right here, I've got -2x. I'm going to write it up here. So I've got -2x in that lead term there. In this lead term, it's x, but it's squared. In this one, it's also x, and it's squared. So if I multiply these together, that's my lead term. All right, so that's going to be -2x to the 5th. There's my lead coefficient. It's negative, which means the right side is going down. And then it's to the 5 power, which is odd, which means the left one does the opposite. So there's what my end behavior should look like. The left side's going up, the right side's going down, which looks like B. All right. Sketch this rational function. Okay, so on the rational function, remember you got a vertical asymptote and you have a horizontal. I'll just abbreviate that one. All right, now the vertical asymptote, remember now, it's going to give you a 0 in the denominator, which in this one, what's going to make me have a 0 there? It'd be -4. So x equals -4. Okay, now, the horizontal asymptote, and I don't know where my notes are from where I wrote this before. All right. Well, I'll just write them again. Remember, for the horizontal asymptote, you're looking at the degree in the top and the bottom. So you're looking at your degrees. So the first one, if the degree in the denominator is greater than the degree in the numerator, okay, then your horizontal asymptote is going to be y equals 0. Okay, number 2, if they're the same, if the degree in the denominator is equal to the numerator, then you have to divide the lead terms. And then number 3, if the degree in the denominator is less than what the numerator is. If the numerator is bigger, there's not one. That gives you oblique. Okay. So I've got to do this. So my degree up here is 1. My degree down there is 1. All right, which means they're equal. So I have to divide the lead terms. Well, if I divide the lead terms, this is 1 out front, this is 1 out front, so I divide these ones. So that'd be 1 divided by 1, which is 1. So it's y equals 1. Okay. So those are my asymptotes. So maybe I could tell which graph it is based on just the asymptotes. So let's see here. X equals -4. So -4 is like 1, 2, 3, 4 right here. Which, you see there's no asymptote on that one. That's out. Now here's one. It could be. Because see my asymptote there? Here's one it could be. not this one. So based on the vertical asymptote, it could be one of these two. All right, now based on my horizontal asymptote, y equals positive 1. Y equals positive 1 right here. This could be it. Okay, this is out because that's negative 1. The answer is B. Okay. All right, number 20. If f is 1 to 1, find an equation for its inverse. Okay, looking at this, this is 1 to 1. Now, how you know it's not 1 to 1? If you have x squared, remember this now, if you have x squared, that's going to be a parabola like this, which is not 1 to 1 because if I have a value of, well, see, it's possible I could have two x values with one y value. So like I could have this x value here and this x value here for whatever y value this is right here. So it's not 1 to 1. If a function is 1 to 1, it should pass the vertical line test and the horizontal line test, which this one doesn't. So this is not 1 to 1. So just remember, if you have x squared or even power, that's not 1 to 1. And so it would be not 1 to 1. It would be D. But on this one, it is 1 to 1, so we can do it. So remember now, we got f of x equals 7x plus 5. I'm going to change this to y, so it's step 1, change this to y. And then number 2, I swap x and y. And then step 3, I solve for y now. So if I solve for y, I'm going to minus 5 on both sides, which gives me x minus 5 equals 7y. And then I would divide by 7. Make the 7's cancel. And there you go, y equals x minus 5 over 7. So there you go, I solve for y. All right, so step 4, I change this to f of x, or f inverse of x. And that should be my answer right there. And see, f inverse of x looks like B. Yep, that's right, B. Okay. All right, 21. Write equation for the graph given. Okay, this is an exponential. All right. They all have base 2, if you notice the answers here. All right, now notice what first thing I see my asymptote down here? It's supposed to be on the x-axis. So it's gone down 1, 2, 3, which means I have vertical shift of down 3. So that tells me it's A or B. This is out because, see, this is plus 3 and that says plus 3. See, these are down 3. So it's A or B. So these are out. Okay. Now, after that, I'm looking for the point that's one value up from the asymptote. Here's my asymptote, and I'm looking at that point right there. See how it's one up from the asymptote? That point tells me about my horizontal shift. It's supposed to be on the axis. See how it's going back 1, 2, 3? It's shifted back this way 3. So remember now, your horizontal shift is opposite. So since it's gone back to the left 3, that should be x plus 3. So it looks like B is my answer. Okay, we got another one of these. 22. Write an equation for this one. All right, see, my asymptote is going up 1. So that tells me I've got vertical shift up 1. So that's going to be plus 1. So it's going to be B or D. This is out. See, it says minus 1. He's out. That says minus 1. It's got to be B or D, right? Because they both have the right vertical shift. All right. Now, I look for the value that's up 1 from the asymptote. So here's my asymptote, and the value that's up 1 is right here. Okay. That should be on the y-axis. So you can see it's shifted over. It's gone to the left. It's gone to the left 2, which means it's the opposite. So when I go to the left, that should be plus 2, which is this one here, B. B is my answer. See, this is -2. So B is my answer. Okay. Number 23. The amount of 709 milligrams of an isotope is given by this right here. So we got this function right here, where T is time in years since the initial amount of 709 milligrams was present. Find the amount to the nearest milligram left after 60 years. So this thing deteriorates slowly. How much is going to be left after 60 years? So if you notice, T is time in years. So I'm going to put 60 in for T. So I'm just going to punch this in the calculator. All right, that's all we're doing. So I've got 709. Make sure you can see the calculator here. Then I've got E. Here's my E button right here. If you notice, right there. This LN, usually the LN button has the E button, so I have to hit second and then hit that. Second, hit that, and then my E comes on the screen. All right, and the rest of this is in the exponent, so I just put in the exponent. So I'm going to go negative 0.025 times 60. And there you go, 158.199. So it looks like 158 here, D. Okay. Now, some calculators, when you type this in, 709E, it puts a parentheses right here. It has an exponent and a parenthesis. And so you just put negative 0.025 times 60 in the parentheses. Now, if you are not able to figure out how to type that in, maybe yours doesn't do either one of these that I did, then, you know, contact me and I'll help you figure out how to get it typed in, okay? All right, 24, solve this equation. All right, so we've got log x plus 1 of 20 equals 1. All right, to solve a log equation, you have to raise it as an exponent of whatever base is. So this is base x plus 1. So what I'm going to do is I'm going to raise this as exponent. X plus 1 to this power equals x plus 1 to the 1 power. Okay? So x plus 1 to this power equals x plus 1 to that power. Well, when I do this right here, these cancel, and I just have 20. Equals, when I do x plus 1 to the 1 power, that's just x plus 1. And now I'm minus 1 on both sides, and I get 19. So it looks like B. All right. What we have here, graph this log equation. All right, remember now, on a log, it has a tail that goes down like this. So looking at this, see my tail goes sideways? These right here are exponentials. Both of these two are. That's not right. See, this has a tail going down. This has a tail going down. So it's one of these two. Okay. Now, look at what the transformation's doing. See this x minus 4? See, the 4 is in there with it. That's different than this. Look here. See, if I had this, see, this is totally different. This is going down 4 right here is what this is doing, because this is not in there with the x. This is horizontal, which does the opposite. It's going to make it go that way 4. See the difference? This is in there with the x, which is horizontal. So I'm doing the log of the 4 along with the log of x. So all that together, that's going to move it horizontally, whereas this moves it down. So this is going to move it over horizontally, which looks like this one. See, it's gone over 4 there, A. See this one here? This has gone down, is what it's done. So that's done this, which is not right. So my answer is A. Okay, 26. Graph this function. All right, now this one here, this one has vertical shift. So see, here's my log, but then I'm going up 2, so it's going to move it up 2. All right, so now looking at it, all right, look here. See my tail to the left here? These are exponentials. They're not logs. See, here's a log, the tail's going down. Here's a log, the tail's going down. So it's one of these two, A or D. Now, which one is it? Well, I want the one that's going up 2. Well, this one looks like it's going back 2. This one looks like it's going up because, see, this point is usually here, so it looks like it's going up 2. So the answer should be D. Okay. Yeah, here's another one. There's a bunch of these. Match the function with its graph. All right. This is a log again, which the tail's going down. Now, look here. All these have tails going up and down. See, this tail's going up, down, down, down. So all these are logs. Now, actually, this one's not right because this tail's going up, which means it would be a negative in front of here, and it don't have a negative. So that one's out. It is going down like this. Now, what kind of transformation do I have? Well, right here, the -1, I'm doing the log of it. It's in there with the x, which means it's horizontal. And it goes the opposite direction. So this should go to the right 1. All right, well, look here. This one looks like it hadn't moved any at all. So I don't think it's that one. This one looks like it's moved to the left 1. And this one here moved to the right. So there's my answer right there, C. Okay. 28. All right. 28, we're going to expand this logarithm out. We got log base 3 of all this stuff in here. So if I expand that out, it's going to be log base 3 of the x to the 4. I'm multiplying those, which means I'll plus log base 3 of y to the 7. But I'm dividing by this, so that means I'll minus log base 3 of 5. Okay, so that's the first thing I do. These up here will be pluses because they're on top, and this will be a minus because it's on the bottom. Now, there's one other thing I do. These exponents can come out in front as multipliers. So this 4 will come out in front of this. There you go, and that's what I've got there for that one. Plus, this 7 can come out in front of that one. The minus, and this one here just stays because it don't have a exponent. So this should be my answer right there. Now let's look through here and see which one. Well, that ain't this one. All right, 4 log base 3 of x plus 7 log base 3 of y. All right, that says plus. That ain't it. I thought we had it there for a minute. This ain't right. It's got to be D. 4 log base 3 of x plus 7 log base 3 of y minus, yeah, it's D. There we go, D. Okay. Now solve this exponent equation. All right, so I have 3 to the x power equals 16. All right, so to solve an exponent, I'm going to do a log. So I'm going to do log base 3 of both sides. Okay, log base 3 of 3 will cancel, so x equals log base 3 of 16. All right, so I'm going to punch that in. Now remember, to punch this in, I'm going to do log of 16 divided by log of 3. All right, so let's punch this in here. All right. So I'm going to do log. Here's my log button right here. See, log. So I'm going to hit that, log. 16. Close it up. See, I got my parentheses there. I have to close the parentheses up. Divide by. Then do log again of 3. That should be it right there. 2.523. 2.524 right there. Rounded it. See there. The 7 makes the 3 go up to a 4. So that's C. Okay. Number 30. Suppose f of x equals all this. So here's my function. Model salinity of water with to depths of 1,000 meters at a certain latitude. In the model, x is the depth in meters, and f of x is the grams of salt per kilogram of seawater. See, the further down you go, the more salt you have. Approximate the salinity to the nearest hundredth when the depth is 930. So that's your depth, which is x. See, the depth is x. So I'm just going to put 930 in for x right there. So basically, you're just going to type this equation in. So let me get my calculator here. All right, so I got 30.6 plus 1.5 log, and then in parentheses here, I'm going to have x, which is 930, plus 1. Or I could have just typed 931. And let's see here, 35.053. Looks like C. Okay, and then the last one here, solve the system by substitution method. Okay, now on this, we see right here, x equals 3y. So I'm going to take 3y and put it for x up there. So right here where x is up here, minus 2y equals 1. I'm going to put 3y in for the x. So x equals 3y. I'm putting that right there where x is. 3y minus 2y is 1. So 3y minus 2y is just 1y. So there you go, y equals 1. Okay, the only one that has y as 1 is right there, this one. So it's got to be B. But if I plug it back in now, if I plug y1 right here, so I have x minus 2 times 1 equals 1. X minus 2 equals 1. Then I would add 2. And x equals 3. So there you go. There's the solution there, 1, 3. The answer is D. Or what I could have done, I could have just plugged in these values. See if I plug in -3 and -1. So -3 plus 2 would be -1. See, it don't work that equation. If I put 3 in here for x and put 1 for y, 3 minus 2 would be 1. Now that works. But if I put it down here, oh, that is my answer. 3, 1 right there. I wasn't paying attention, man. It's early. It's not D. If I put 1, 3 in, 1 minus 6 would be -5. That ain't right. But the answer is B. I don't know why I did that. But it should be 3, 1. And that's it, man. That is our final review. So you study up, and if you have any questions, please contact me, and I'll help you all I can, all right? So have a good rest of the day.